Hello, wherever you are. Welcome to this class. So this is the continuation class of process costing. Remember, we did process costing without work in progress. Then afterwards, we introduced process costing with work in progress. And then now we are going to introduce process costing with joint product and byproduct. So situation where we have joint product and byproduct. So without wasting any time, let us jump into process costing for joint and byproduct. So we have byproduct and joint product. Now when we talk about joint product, these are two or more products produced in the same process and separated at the sprint of point. Then joint product in most cases have significant value. So in most scenario, you find that joint product has significant value. Now production cannot be separately identified until you reach to a certain point, and that point is called the sprint of point. So until we reach to sprint of point, we cannot identify the product. So the product cannot be separately identified. So we can only identify the product until we reach to the final, where we separate maybe from, for example, crude oil. We separate it from we separate crude oil so that we come up with petrol, diesel, and kerosene. Now, if we haven't reached at sprint of point, then production cannot be separately be identified. Then you have byproduct. No, byproduct is a secondary product obtained from the main product, and it has a minor value. So it has a value, but its value is not that significant as compared to joint product. So remember, joint product are the main product, and therefore the value is significant. Their value is significant. You sell them at a very good price. Now, for example, in the production of sugar cane, when we produce sugar, sugar is the main product, and that sugar can be termed as a joint product. But we have molasses, which it is obtained from the same. So molasses is a byproduct. Let us see methods of cost apportionment. So we have various methods. We have three of them. We have three methods of apportioning the cost according to this method. So let us see some of those methods. So we have various methods. So we have methods of apportionment when it comes to joint product, and you have method of apportionment when it comes to byproduct. For joint product, we have three methods. We have the physical units method, where we apportion the cost using the quantities like kg, liters, and units. Then we have sales value at sprint of point. Now we apportion cost based on the relative value of those items at the sprint of point. Then you have the NRV, the net realizable value. We also call the after further processing method. Now it used if product requires. So we use this method in a situation where there is further processing after sprint off. Now NRV is equal to the final sales value minus further processing cost. Apportionment joint cost. This one it's apportion joint cost based on NRV. Then you have the byproducts. We have two methods. We have the reduced main product cost, and you have the treat byproduct as same separate income. Now the first one, reduced main product cost. Sales proceed by a byproduct are deducted from the joint cost of the main product, and that is we have the formula there. Adjusted cost is equal to total joint cost minus byproduct sales value. And the other one, revenue of byproduct is treated as other income, and therefore the cost allocation of the main product will always remain unchanged. Now I think it will be prudent if now we look for a question. Let us look for a question from a past paper. So let us look at November 2017, question number 5B. November 2017, question number 5B. November 2017, question number 5B. The question reads, Tegemeo LTD manufactures a product which yields three joint products H and T. The joint products are then processed further in a common process which consists of two stages. So we have stage 1, which is process 1, and process 2. Then we have some additional information. We have some additional information there. For output 1, the output of process 1, which will be transferred to process 2 to form 26,000. Then the output of process 2, it is made up of various products, product H, N, and T. So normal loss for process 1 and 2 is 10%. Selling price for H, N, and T is 180, 200, and 300. All joint products are sold as soon as they are produced. The sales method of joint cost is used in apportionment. So joint cost. So sales value. So they are using sales value. Now we are going to prepare process 1, process 2, and process 3, and income statement. And the income statement. So let us do it together. So November 2017, 5B. So November 2017, 5B. So So let us start with the process 1 account. And also process 2. So we have prepare process 1 and process 2. Now process 1, we just start direct with direct material, which is 600,000. Then you can see it. So just say direct material. It is 600,000. So you can say 600,000. So it is not a requirement to write the units, but you can also include the units. And then we have other cost there. We have conversion cost, 765. Conversion cost. $765,000. So we do not have any other cost. Let us compute normal loss here. Normal loss units. Now normal loss information number 3, 10%. It is 10% of normal loss of our units. Our units is 30,000. So 10% of that is, I think it is 10% of that is 3,000. 3,000. So that our normal loss amount, so itakuwa ngapi? Normal loss amount itakuwa ni 3,000. So remember, it goes hand in hand with scrap value. So it goes hand in hand with scrap value. So what's our scrap value from the question? Information number The first one, process 1, the scrap value for normal loss is 5 shillings. We multiply by 5. So that will be 15,000. Then let's check abnormal gain or loss. So we compute expected production. So expected production, we take the inputs, which is this one, 30,000, minus our input, 3,000. We are getting how much? 27,000. Then we compare it with output or actual production. So what is the output for this process? Output. Now information number 1. Information number 1 says the output in process 1 transferred to process 2 is 26,000. So it is 26,000. So we compare the two. 26,000, a difference of 4,000. So is it a gain or a loss? Then it's abnormal loss. So abnormal loss. So how much will be abnormal loss? So 1,000. We multiply with the cost per unit. So that one goes hand in hand with the cost per unit. So we need to compute cost per unit. So we need to compute cost per unit first before we find the normal loss amount. So before we find the normal loss amount, so cost per unit. So we add this together. So 0, 0, 0, 5, 6, 13. So I think it is 1365. So total cost is 1365,000 minus our normal loss 15,000. We divide with the expected production. This one expected production 27,000. So you divide with the expected production. So 1365,000 minus 15,000 divided by 27,000. 50. So meaning our abnormal loss amount itakuwa ni units, which is 1,000 times 50, which is 50,000. Then we also need output. So output, we have output which is 26,000 times 50. So 26,000 times 50, which is 1,300. So we add together plus 50,000 plus 15,000. So that is 1365. 1365,000. So that is how we do process 1. So that's how you do process 1. Let's go to process 2. Now process 2, we start with output, which is input now. Input of 1.3. So we start with that first. So the output becomes the input. And then after that, we go to our equation. Process 2, we have been from direct material. So direct material. Now, but direct material is dash. So in process 2, if we check the equation, process 2, direct material, we do not have direct material. Then you have conversion cost. Conversion cost. And remember, units is 26,000. 2262,000. 2262,000. 2262,000. Now let's compute normal loss for process 2. Normal loss units, which is 10% of our input. Now our input is 26,000. So output 26,000, which is 13. This one 26,000, which will give us 2,600. Then expected production. Production is 26,000. So that's the input minus loss 2,600. So itakuwa 26,000 minus 2,600, which is 23,400. Now we compare with actual production. Actual production or output. So we compare with it. So what's our output for process now 2? So output, now information number 2, let's read information number 2. Output for process 2 is made up of the following item. So we have H, N, and T. So let's add them together. 10,000 for H, then N 7,000, then T 6,000. So you add the 3. 10,000 plus 7,000 plus 6,000. So 23,000. Then we either get abnormal gain or loss. So 23,400 minus 23,000, which is 400. Now this one is a gain. So we have abnormal gain of 400. So expected no, it's okay, it's fine, it is fine. It is a loss. Okay, let me see first. Let me see. Just a moment. Just a moment. So so that will be a gain. So the second one, it will be a gain. It will be a gain. So we put abnormal gain here. Now, normal loss. Let's compute normal loss. Amount. So let's compute normal loss amount. So normal loss amount. You pick our normal loss, which is 2,600. You multiply with the cost per unit for the scrap. So let's go to the scrap value. Scrap value for process 2 was 20. 20. So 2,600 times 20, that is 52,000. 52,000. What else do we need? Now we need this abnormal gain, but before we do that one, we need the cost, total cost. So cost per unit, so it is 13 plus this, so 1300 plus 2262,000, which is 3562 minus 52,000. You divide it by 23,400. So minus 52,000 divided by the 23,400. So I'm getting 150. So meaning abnormal gain amount. This one abnormal gain amount, it will be 400 times 150. So 400 times 150, which is 60,000. 60,000. Then you also need abnormal loss amount. So it's 0 because we do not have any. Then output. Now our output, we have a total output. So 10 plus 7 plus 6, which is 23,000 times 150. So 23,000 times 150, 34,50,000. So that we add them together, plus 52,000, 502,000, and then what? This one, 62,000 plus 60,000. It is not. It's not what? Balancing. 1300 1 2 3 plus 62,000 plus 60,000. So in assignment is 3622. Let us see normal loss. 26,000, 2600 times 20, that is 52,000. We do not have normal loss. So we use this one. So 1300 1 2 3 plus 22,62,000, that is 35,62,000 minus 52,000. Then we divide by the expected production, 23,400. So I'm getting 150. So 150. So we multiply with the output, which is 23,000 times 23,000, 34,50,000. So plus 52,000, 3502. So what could be the problem? So what could be the problem for this account? I think it is not balancing by some small amount. So 10% of 20. Let us confirm this is correct. 10%. Where is that calculator? So the rate was still the same, 10%. So 10% of 26, 0.1 times 26,000, that is 2,600. Then 26,000 minus answer, that is 23,400. Then minus 23,000. Use 17, 18, 19, 20, 21, 22, 23. That is correct. So that we get 400 as abnormal gain. That is 400. 400 times 150, that is 60,000. So that one is fine. I don't know where we are getting it wrong. Let me see. So 23. Oh, I have seen where we have made a mistake. No, it is a loss also. This one is not a gain. This one is also a loss. It's not a negative figure. Why did I put a negative figure? So it's not a negative figure. It's a loss of 400. So meaning, in this case, you don't have figures, but in this case we have 60,000. So that is abnormal loss. So it's supposed to be a loss, not a gain. It's supposed to be a loss and not a gain. So let us confirm now. 52,000. So it will be 13,00123 plus 22,62,000. That is 32,62. 32 what? 62,000. So 32, not 32, 35. Now in this case, 52,000 plus 60,000 plus 34,50,000. So 35,62. Allah. So let me add 1,300 plus 22,62. That is 13 supposed to be 1300 plus 22,62. 35,62. It's supposed to be 35,62. So also this one is supposed to be 35,62. So let us confirm 52,000 plus 60,000 plus 34,50,000. 35,62,000. That is correct. That is correct. Now we are to apportion. So allow me to rub the other side so that we can apportion. So let us see the apportionment. Now when it comes to apportionment, this question requires us to use the sales method. The sales value method. Now for the sales value method, we need to first compute the total sales. Now for us to compute the total sales, we use the output. So remember this output, this one 23,000. It was made up of N, H, and T with their value 10,000, for example, the first one times 180, and then 7,000 times 200. So for sales value, you take the units. For you to get the sales value, you take the units times selling price. Selling price per unit. So from the question, information number 2. Let's go to information number 2. We have the units, as you can see. Then look at information number 4. The selling price per unit, we have 180, 200, and 300. So you multiply the units with the selling price to get the total sales. Then you add them together. So when you add them together, you get the total sales is 5 million. This one. Now we are apportion now using the. So let us apportion the sales value. So you take the sales divided by total sales. So sales of N divided by the total sales. so that we need to apportion this cost. Now this one is our joint cost, this one. So the final cost is the joint cost, and that is what we need to apportion. So the final cost in this case for process 2, the output, that is the final item, that will make the joint cost, and that is the cost that we need to split off at the end. So we split using the sales value method, and in that case we used our sales. So in that case we take our total sales, we divide with sales for n, we divide with the total sales. So 1800 times 5000, you multiply with the joint cost to get 342. You also do for n, 14 divided by 5000 times 3450. Then for t, 18 divided by 5 million times 34. Then you get your joint cost. Now, for us to come up with the income statement, you take sales, you minus cost. The sales, we have them H, N, and T. 18, 14, 18. 18, 14, 18. Then you less our joint cost. 14, 42, 14, 42. 966, 966. Then 1242, 1242. Get your profit. So that is it. So that's how you do. That's how you do for for sets. That's how you do for sets. Now, if you are to do for the first method, and that first method was the quantity method, where we are using quantity, physical quantity method. Let me show you. Now, when we talk about physical units, as you can see here, physical units, we take the number of units. For example, 10, 7, and 6. So we add 10 plus 7 plus 6, which is 23 total. So we take 10,000 divided by 23 times that 450, you get your cost. Repeat for the same 7 divided by 23 times that 450. You also do for 6,000